We from Graphics Lab IIIT Delhi present our work on SLI-pSp, injecting multi-scale spatial layout in PSP. Our proposed SLI-pSp approach helps fix the lack of spatial context in StyleGAN based image-to-image translation methods like PSP. By injecting spatial layout information in the decoder, we retain the global properties of image generation even after our spatial layout injection. On probing further, PSP broke down when tried on other datasets with more variation and complexity such as places 2 dataset. We hypothesize that this is due to a lot of high frequency information and numerous objects in the scene that are insufficient to be captured without the transfer of input spatial layout information. Previous methods like PSP seem to miss the finer or underrepresented details. We propose a technique termed spatial layout injection that encodes spatial layout information in the input image in the StyleGAN generator along with style. We do so without modifying the style vector injection in the generator that helps preserve the stylization properties of StyleGAN. We provide a general framework that can be extended to modern attention-based methods that show improvements. We show both quantitative and qualitative improvements across a wide variety of tasks and data. We extract feature maps using the feature pyramid network, which are then propagated via the map to style and the SLI blocks and injected into the StyleGAN generator. We strategically embed the feature maps from the encoder by combining it with the noise layer in the generator without changing the style injection via map to style in the network. Since the noise is injected separately and allows for local stochastic changes, this makes it suitable location for the injection of the features. Further, since StyleGAN uses hierarchical generation, we restrict feature injection to lower scales to ensure higher flexibility. This approach ensures that style propagation via the map to style network remains unhindered, whilst the scene layout information is also injected into the generator. We can see this in the multimodal generation. The results are at par with the original PSP network. Here, we again see the amount of diversity captured in the multimodal synthesis by our method. Here, we show results on the set to fake task and compare it against several different methods and find that our method is at par with PSP. We observe quantitative improvement across a variety of tasks. Further, we also show additional improvements that can be obtained by a simple attention-based variant of the method. We see improvements in segmentation map to image and super resolution, along with the new dataset of edge to image tested on places 2 dataset. We show additional results for segmap to face image generation by the SLI-pSp method. Here we show the qualitative results for our method. We see the profound difference that the spatial layout injection leads to. It helps capture the finer details which are missed in the PSP framework. For super resolution tasks, we again see that our method is at par with the PSP framework. Further, we also see for AFHQ dataset, our method is able to capture the finer details in a much more profound manner. We discover that due to the global approach of PSP and the lack of spatial layout context in the image generation process affects when high frequency details are needed in a conditional setting. SLI-pSp codes the spatial layout information from the input image and propagates it to the StyleGAN decoder. SLI-pSp combines the multi-scale encoder feature maps with the noise layers in the StyleGAN generator without modifying the style propagation component. We demonstrate through our detailed experiments that we don't replace the global context with local, but rather amplify the spatial layout details required for many eye-to-eye tasks. While we achieve good performance across these tasks, we do notice some artifacts attributed to locality bias, despite a better performance in terms of FID scores in some cases. We hypothesize that the artifacts observed in super resolution are due to strong locality bias without tight correspondence to the output. Since our key focus is on improving synthesis quality, we leave inversion for future research. Thank you.